Hello students, hope you are doing well. Welcome to the lecture 2 of lecture series 11th Mathematics. In the last lecture we covered the concepts in the chapter of angle and its measurements. In this lecture we are going to solve few questions from that chapter. I've taken 5 questions. I've selected 5 questions from the 11th standard state textbook, Maharashtra State Board textbook, and the questions are there on your screen. What we'll do is we'll solve these questions. Okay, so let's start with the first question. So what is the first question? It is given that the radius of the circle is 9 centimeter. We have to find out the length of arc of the circle which cuts off a chord of length equal to the length of the radius. Okay, fine. Chalo. So we have a circle. In that circle, we have a chord. We have a chord like this. This is the center of the circle. Let the chord be AB and the center be O. Fine. Then OA is the radius of the circle and OB is also the radius of circle. So in this case, we get a equilateral triangle OAB with all the sides equal to R, which is radius of circle, Fine. What we have to find out is the length of this arc AB. Now, from the length of arc formula, we know S is equal to R theta, where theta is in radians, and R is the radius of the circle. Theta is in radians and theta is the angle subtended by the arc, this arc at the center of the circle. So, which is this angle. Now, since triangle OAB is an equilateral triangle, we have angle AOB is equal to 60 degree, which is 60 into pi by 180, which is pi by 3 radians, Okay, fine. Now, using the formula S is equal to R theta, we calculate the length of arc AB as follows, which is equal to, what is the radius of circle? The radius of circle is 9 centimeter as given over here. So it is 9 centimeter into pi by 3. So that is 3 pi centimeter. So the length of the arc AB is 3 pi centimeter. What we have done? We have constructed the triangle OAB according to the given conditions, where the length of the chord AB is equal to the radius of the circle. Therefore, we have an equilateral triangle OAB, and therefore all the angles in the triangle are 60 degree. Then the chord AB subtends an angle 60 degree at the center, and then using the formula S is equal to R theta, we calculate the length of the arc AB as 3 pi centimeter. Very good. Let's move to the next question. Fine. So in this question, it is given that there is a pendulum of length 14 centimeter. So we have this center of pendulum, and let's say this is the first one extreme position of the pendulum. And it is said that the pendulum oscillates through an angle of 18 degrees. So the second extreme position is, let's say, this. So these two are the extreme positions. So what we have to find out? This angle is given as 18 degree. Since the pendulum is oscillating by an angle of 18 degree, we have to find out the length of its path. So what is the length of the path? This is the length of the path. And that forms an arc. Again, we'll name this arc as AB, this center angle as O. Fine. So now this whole figure, you can see it as a part of a circle or as a sector of the circle. We have to find out this S over here, and when the given angle is 18 degrees, we can use it in the formula S is equal to R theta, but we have to convert 18 degrees first into radians. So 18 degrees into radian goes to 18 into pi by 180 radians, which is equal to 18 tens are 180, so it is pi by 10 radians. It is pi by 10 radians. Okay, and this length of the pendulum is given to be 14 centimeter. Okay, which can be considered as the radius of the circle. So we have S is equal to r theta formula, fine, where r is the length of the pendulum, r is the length of pendulum, fine, and S is the length of path of the pendulum, So substituting the values, we get 14 centimeter into pi by 10 radian, so that is 2 sevens are 14, 2 fives are 10, which is 7 pi by 5 centimeter. So the length of the path of pendulum is coming out to be 7 pi by 5 centimeter. Okay, fine. Chalo. So that was our second question. Let's move towards the third question. Okay, fine. Now, this is a good question. It is given that the perimeter of the sector of the circle of area 25 pi square centimeter is 20 centimeter. So what is given? It is given that perimeter of the sector is equal to 20 centimeter and area of the circle is equal to 25 centimeter square or square centimeter. Now we know area of the circle is pi r square centimeter square, correct? Fine. Oh sorry, it is given as 25 pi. So let me just adjust it over here. 25 pi centimeter square. Centimeters. Okay, fine. Okay, so from over pi and pi gets cancelled. We have r square is equal to 25. So r is equal to 5 centimeter. Fine. R square is equal to 25 centimeter square. So r is equal to 5 centimeter. So from the area of circle, we can calculate the radius of the circle. Now, have a look at the diagram. It is very important. So now this is the diagram like this. This is the circle. Fine. Nothing is mentioned about the angle that the arc makes at the center or the arc subtends at the center. It is just given that there is a sector like this. Sector, this is center O, this is radius r, this is radius r, and this is the length s of the arc. This is the length s of the arc. I'll highlight. It is given that the perimeter of the sector is equal to 20 centimeter, and from the figure we can see that the perimeter is nothing but r plus s, which is equal to 2r plus s, which is equal to, when we 2 into 5, when we substitute r is equal to 5, 2 into r plus s, which is equal to 10 plus s. So 20 is equal to 10 plus s. Therefore, we are getting the length of the arc as 10 centimeter. The length of the arc as 10 centimeter. What we have to find out? We have to find out the area of the sector. We have to find out the area, this area of the sector A. This area of the sector A. Now, what is the formula for area of sector? The formula for area of sector is half into r square theta. So we have the value of r, but we do not have the value of theta. So from where do we calculate it? We calculate it using r. We calculate it using s. S is equal to r theta. S is 10, r is 5 into theta. So theta comes out to be 2 radian. 2 radian. Now substituting that value of theta in the formula for area, area is half into r square into theta. Theta again should be in radians. So we have half into 25 into theta is 2. 2 and 2 gets cancelled. So area is 25 square centimeter. So the area of the sector, whose perimeter is 20 centimeter, for the given area of circle as 25 pi square centimeter is 25 square centimeter. So the area of the sector is 25 square centimeter. Okay, fine. Sure. That was our third question. Let's move on to the fourth question. Okay, very good question. A little bit of solving is required in this question. Angles of quadrilateral are in AP. Now, what is the meaning of AP? AP means it basically, AP is the abbreviation for arithmetic progression, which means that we have few terms and each subsequent term is, so what happens is basically if we have, let's say, 4 terms, 1, 2, 3 and 4, the difference between all the terms is same. The difference between all the terms is same. Okay, fine. So that is an AP. That is an AP. So which means that if you have to find out the further terms or the subsequent terms, you have to add the common difference in the initial terms. You have to add the common difference in the initial terms. It is also given that, so what is given? The angles of the quadrilateral are in AP. It is also given that the greatest angle is double the least. The greatest angle of the quadrilateral is twice that of the smallest angle. So we have to find out the angles of quadrilateral in radian. We have to find out the angles of quadrilateral in radian. So let's say the angles are angle 1, angle 2, angle 3 and angle 4. Okay. Let's say that angle 1 is having a value A. Now, by using the concepts of AP, angle 2 will be A plus X, where X is the common difference. On the same lines, angle 3 will be A plus 2X and angle 4 will be A plus 3X. Angle 4 will be A plus 3X. Now, it is given that the largest angle or the greatest angle, which is angle 4 from our definition, it is twice that of the smallest angle, which is angle 1. So, according to that condition, A plus 3x is equal to twice of A. And from that we have 3x is equal to A. So, we have got a relation between x and A. 3x is equal to A. Fine. And these are the angles A plus x, A plus 2x and A plus 3x. Okay. Now, we know that sum of all the angles of a quadrilateral is equal to 360 degree. Now using this, we can write down A plus x plus A plus 2x plus A plus 3x is equal to 360 degree. Now let's simplify this. A plus A plus A plus A plus A plus A plus A, that is 4A, plus x plus 2x 3x, 3x plus 3x is 6x. So 6x is equal to 360 degree. Now using this relation 3x is equal to A, we can substitute for, in the place of 6A, we can substitute 2A. Okay, 3x is equal to A, therefore 6x is equal to 2A. Fine. Chalo. Now let's simplify. This 4A plus 2A is 360 degree. Therefore 6A is 360 degree and therefore A is equal to 60 degrees. So the first angle is 60 degree. Okay, which is angle number 1. Then if A is equal to 60 degree, we know that A is equal to 3x. Therefore x is equal to 20 degrees. X is equal to 20 degrees. We have used this relation. 3x is equal to A. Fine. Chalo. So what we are having? We are having A is equal to 60 degree and x is equal to 20 degrees. This is what we are having. Fine. Now let's find the angles. Angle 1 is equal to A is equal to 60 degree. Angle 2 is equal to A plus x is equal to 80 degrees. Angle 3 is equal to A plus 2x, which is equal to 100 degrees. And angle 4 is equal to A plus 3x, which is equal to 120 degrees. Fine. So these are all the angles of the quadrilateral. But this is not the complete answer. We have to convert them into radians. So 60 degrees, when converted into radians, we have 60 into pi by 180, which is equal to pi by 3 radian. Then 80 degrees when converted into radian is 80 into pi by 180, which is 2 4s are 8, 2 9s are 18, which is 4 pi by 9 radian. And okay, so 60 degree is equivalent to pi by 3 radian, 80 degree is equivalent to 4 pi by 9 radian. Then we have 100 degrees, which is equivalent to 100 into pi by 180, 2 5s are 10, 2 9s are 18, 5 pi by 9 radian. And 120 degree, which is equivalent to 120 into pi by 180, 6 2s are 12, 6 3s are 18, which is pi by 3 radian. Sorry, 2 pi by 3 radian. Fine. So the angles of the quadrilateral, are, what are the angles? So we have pi by 3 radian, then we have 2 pi by 3 radian, then we have 4 pi by 9 radian, and 5 pi by 9 radian. Okay, so these are the angles of the quadrilateral: pi by 3 radian, 4 pi by 9 radian, 5 pi by 9 radian, and 2 pi by 3 radian. Fine. Chalo. So that was question number 4, I guess. Okay, a very good question, where we have to find out the angles of quadrilateral which are in AP, and the greatest angle is twice that of the smallest angle. Okay, so this is the final question of the video. Let's read the question. We have triangle PQR, and it is an equilateral triangle. It is an equilateral triangle of side 18 centimeter. A circle is drawn on the segment QR as the diameter. So segment QR of the triangle is used as the diameter. We have to find out the length of the arc of the circle which is within the triangle. We have to find out the length of the arc of the circle which is within the triangle. So let's draw the diagram. First we'll draw the circle. We'll draw the circle like this. So this is the, and that will draw the triangle. So this is the QR which acts as the diameter of the triangle. Fine. And then like this, this is the other two sides of the triangle. So this is PQR. This is PQR triangle. This side is 18 centimeter. This total side is 18 centimeter. Complete side is 18 centimeter. Fine. This is the radius of the circle. This is the radius of circle. R is equal to radius of circle, and that is nothing but half of the diameter. So it is 9 centimeter. Fine. What we have to find out is the length of the arc, which is within the triangle. So this part is within the triangle. So we have to find out the length of this arc. Let's name this arc as AB. Fine. Now let's connect the endpoints to the center. Fine. So if you have to find out this length of the arc AB, that is SAB, we require this angle theta, which is subtended at the center. Now this triangle is an equilateral triangle. So angle Q and angle R. Angle Q is equal to angle R, which is equal to 60 degrees. So this is 60 degrees and this is also 60 degrees. Fine. This is radius. This line is radius. Fine. This is also the radius of the circle. So this is R. Now by using the property of isosceles triangle, this angle is also 60 degree. Why? Because this side and this side are the radius. So the angle subtended by those two sides on the base will also be equal as the radius, as they are the radius and therefore equal. This is the radius. This is the radius. Fine. So the angle subtended by them at the base will also be same. So if this is 60 degree, if this part is 60 degree, this also is 60 degree. Fine. Okay. Now what we are getting is 60, 60, 60. So this is an equilateral triangle that we are getting. These two triangles are equilateral triangles that we are getting. Let me just erase out this mess. I'll draw it again. So I'll draw the triangles in the interior. So this triangle, okay, yeah. So these two triangles that we are having. Fine. These are the two triangles, and these two triangles are coming out to be equilateral triangles. 60 degree, 60 degree, 60 degree. This is also 60. This is also 60. This is also 60. Now see, this is 180 degree angle. This angle is 180 degree, complete angle. From that, these two are 60 and 60. So this also comes out to be 60 degree. So the angle subtended by arc AB at center is 60 degree, which is pi by 3 radian. Calculate and check. Okay. Therefore, using the formula S is equal to R theta, we can write down 9 centimeter into pi by 3. So this comes out to be 3 pi centimeter. So the length of this arc AB, is 3 pi centimeter. Why? Because that is the arc which is inside the triangle. That is the arc which is inside the triangle. Okay, fine. Sure. So those were the questions, I guess. Yeah, this is the last question. Yes. So those were the 5 questions which I had selected from the textbook of 11th Standard State Board. I hope you liked this video, and do like, share and subscribe. Have a good day. Thank you.